So today I will explain the problems on set theory. So here you have to find the value of n of A intersection B. Again find the common element in both A intersection B. You can expect this question for 8 marks. So you have to prove both the theorems. First find out A union B, then find out A union B whole complement. Hello my dear students, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. In my last session, I have discussed 3 laws of set theory: associative law, distributive law and De Morgan's law. So, in my previous sessions, I have discussed all the laws in set theory. So, today I will explain the problems on set theory laws. Very important questions. So, easily you can score 7 marks in laws of set theory. So, first problem is, let A and B is a finite set. We have two sets, that is A and B, such that n of A is equal to 20. First write all the given values. N of A is equal to 20 and n of B is equal to 28. N of B is equal to 28 and n of A union B is equal to 36. A union B is equal to 36. And find n of A intersection B. So you have to find the value of n of A intersection B. So here the given value is n of A, n of B and n of A union B. So here we have two finite sets A and B, set A and set B. So they have given the cardinal value of set A and set B, that is n of A is equal to 20, B is 28, A union B is 36. So what is A union B? So if we are combining the elements of A and B, so we will get A union B. So the total value of A union B is 36. So now you have to find the A intersection B value. So first write all the given values, and here already I have discussed this formula in my previous session. So this is my formula: n of A union B is equal to n of A plus n of B minus n of A intersection B. So here how to find the value of n of A intersection B? So first substitute the value of given set. So first substitute these values in your equation. So n of A union B is 36 is equal to n of A is 20 plus n of B is 28. You have to find out A intersection B. So what is the next step? 36 is equal to, what is 20 plus 28? It is 48 minus n of A intersection B. So here you have to find the value of n of A intersection B. You just cross multiply this. N of A intersection B is equal to 48 minus 36. So what is the answer? It is 12. So n of A intersection B is equal to 12. So very simple problem for 2 marks. So first write all the given values and substitute to this equation. So sometimes they will ask to find the value of n of A union B. If it is n of A union B means directly you can substitute to this equation n of A, n of B and n of A intersection B. So you will get the value of n of A union B. But here they have given the value of n of A union B. So you have to find the value of n of A intersection B. So using this formula easily you can find out n of A or n of B or n of A intersection B or n of A union B also. So this is a formula for finding n of A intersection B or n of A union B. This is 2 marks question. And the next question is, let A is equal to 1, 2, 3 and phi is equal to null set. So here we have two sets, set A and set phi. In set A we have 3 elements, 1, 2, 3. But in set 5, we don't have any set elements, that is null set. So here we have to find that A union phi is equal to A. So which law is this? This is identity law. Identity law. Identity first law is A union phi is equal to A. So here using this two set values, we have to prove that LHS is equal to RHS value. So first value is A union phi. So first find out LHS value. This is LHS. Prove that is equal to RHS value. LHS should be equal to RHS. So A union phi. First find out A union phi. So what is A union phi here? A union phi is equal to, so what is union operation? You just combine both the set elements, you will get A union phi. So in A we have 3 set elements, but in phi we don't have any elements, it is null set. So what is A union phi now? Again you will get 1, 2, 3 only. Clear? So A union phi is, it is null set, but in set A we have 1, 2, 3. Again you will get 1, 2, 3 only. So 1, 2, 3 means I can write it as A, set A elements. So equation proved. A union phi is equal to, again you will get A only. So very simple concept for 2 marks. So you can prove any type of these questions easily. So here I have 3 sets, set A, set B and set C. So you have to prove that A union B union C is equal to A union B union C, and also you have to find A intersection B intersection C is equal to A intersection B intersection C. So these laws already have proved in my previous session. Using this set elements, how to prove these theorems. So first step. So first I will find this. First find out the LHS value should be equal to RHS value, right? So first consider LHS, that is A union B union C, right? So first find out this value. What is A union B? Cross check this set element of A and B. What is A union B? 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. So elements are not repeated twice in A union B. 1, 2, 3, 4, 5, 6, 7 is my A union B. 1, 2, 3, 4, 5, 6, 7 is A union B. And union C. Just write the set element of C. It is 5, 6, 7, 8 and 9. So this is your set elements of C. So now find out A union B union C. You just combine this 1, 2, 3, 4, 5, 6, 7, 8, 9 is your LHS value. So now find out RHS. RHS is A union B union C. So what is A set elements? It is 1, 2, 3, 4, 5 union. So find out B union C. So B union C is 3, 4, 5, 6, 7, 8 and 9. So now again find out A union B union C. So you will get 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your RHS. So now cross check the LHS value is equal to RHS or not. So in LHS I have 1, 2, 3, 4, 5, 6, 7, 8, 9 and in RHS also 1, 2, 3, 4, 5, 6, 7, 8, 9. So hence it is proved. So LHS is equal to RHS in first theorem. Hence it is proved. So again I have second question. A intersection B intersection C. So first I will consider LHS is A intersection B intersection C. So first find out A intersection B. So what is A intersection B here? 3, 4, 5 is common in both set element A and set B. So 3, 4, 5. A intersection B is 3, 4, 5. Intersection of C. C element is 5, 6, 7, 8, 9. So this is set element of C. 5, 6, 7, 8, 9. So now again find the common element in both A intersection B, intersection C. So which is a common element here? I think 5 is a common in both the sets. So 5 is your answer. So our LHS is equal to 5. So now you have to prove LHS is equal to RHS. So now consider RHS. So what is your RHS? A intersection B intersection C. So now first write the set element of A. It is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And intersection of what is B intersection C? B intersection C is 5, 6, 7, 5, 6, 7. Common element in both set B and set C is 5, 6, 7. So finally, you can find the common element in set A and in B intersection C. So now, which is a common element in both set? So which is a common element out of this? So 5 is a common element in both the sets. So this is your RHS. So just observe the LHS value and RHS value. So finally, LHS is equal to RHS. So this is your final answer. So in first law also we have proved LHS is equal to RHS. In second law also we got LHS is equal to RHS value. So using the set elements easily we can prove the theorem called distributive law, associative law, idempotent law and identity law. Also we can find out De Morgan's law. The next problem is let A is equal to 1, 2, 3. So here we have 3 set elements, but now I have to prove that LHS is not equal to RHS. So first consider LHS. LHS is A union B intersection C. So first find out, write the set element of A, 1, 2, 3. Union, what is B intersection C? So common element in both set B and set C is 3, 4. So common in both set B and set C is 3, 4 is common. So again find out the union here. So 1, 2, 3 and 4. So this is your LHS. So now prove that LHS is not equal to RHS. So now consider RHS is equal to A union B intersection C. So first find out A union B. A union B is 1, 2, 3, 4 and intersection of C. Right? The set element of C 3, 4, 5. So here we have intersection. Out of these you have to find the common elements. So which is a common? 3, 4 is my common element. So 3, 4. This is your RHS. RHS is 3, 4. LHS is 1, 2, 3, 4. Is it equal? So it is not equal to this. So finally LHS is not equal to RHS. Hence it is proved. So using the set elements we can also prove the LHS is equal to RHS or LHS is not equal to RHS. So very simple concept. Just use the operations of union and intersection operation. Easily you can prove the laws in set theory. And the next problem is, if A is equal to A comma B, here I have 3 set element. So you have to prove that LHS is equal to RHS. So first consider the LHS A cross B union C. Already I have discussed this Cartesian product. So A cross B union C. First write the set A element A comma B cross B union C. So what is B union C? 2, 3 and 4. This is B union C. So now you have to find out A cross B union C. This is Cartesian product. So what is Cartesian product? A2, A3 compare with next element. First element you have to compare with the second element. A comma 2, A3, A4. And again B2, B3 and B4. So here I got the LHS value. LHS is equal to A comma 2, A comma 3, A comma 4, B comma 2, B comma 3, B comma 4. I have two set element here. Here I have three set elements. You just compare the elements with second element A2, A3, A4, B2, B3, B4. So this is my LHS value. So now prove the RHS value. So RHS is A cross B union A cross C. So what is A cross B now? So first write the set element of A and B. A is A, B and B is 2, 3. So Cartesian product is A comma 2 and A comma 3. Again B comma 2 and B comma 3. So this is my A cross B. Again have to prove this A cross C. So again you have to prove A cross C. Union of A cross C. A means this A comma B into C is 3, 4. So again, so union of A comma 3, A comma 4 and B comma 3, B comma 4. So now find out union operation again. So what is the union operation? You just take the common element. So now combine all the elements here. A2, A3, A4 and B2, B3 and B4. So now I proved the LHS is equal to RHS. LHS is A2, A3, A4, B2, B3, B4 and RHS is A2, A3, A4, B2, B3, B4. So this is your RHS. So finally LHS is equal to RHS. Hence it is proved. So these type of questions you can expect. So these type of questions you can expect in laws of set theory. And the next question is, let A is equal to 1457, B is equal to 1672 and C is equal to 2468. So here I have three set elements A, B, C and you have to prove that associative law. They have not given the law in detail, just they have mentioned prove associative law. So already have discussed associative law, right? So using the associative law, you can prove that LHS is equal to RHS. So what is your associative law? So associative law is A union B union C is equal to A union B union C. And A intersection B intersection C is equal to A intersection B intersection C. So this is your associative law for union and for intersection operation. So using these laws, you have to prove that LHS is equal to RHS. It is 8 marks question. You can expect this question for 8 marks. So you have to prove both the theorems. So here you have to prove both the laws of union and also for intersection. So here we have three set elements A, B, C. Using the set values, you can find the LHS value is equal to RHS in associative law. So in previous problems also I have explained this type of questions. So you can try out this. This is your assignment questions. Please practice this assignment question. The next problem is De Morgan's law. So using the set elements, how to prove the De Morgan's law? So here we have to prove that LHS is equal to RHS. So here first I will consider the LHS. LHS is equal to A union B whole dash. First prove this LHS. LHS is equal to A union B whole dash. So first find out A union B. So what is A union B? A union B is 5, 6, 8, 2, 4, 5, 8. So 2, 4, 5, 6, 8. Union B is 2, 4, 5, 6, 8. This is A union B. So just combine the elements 2, 4, 5, 6, 8. And here we have whole complement. A union B whole complement. So here you have to prove the A union B whole complement. So how will you find the complement operation? So already I have explained how to find the complement of A. U minus A. If you are using this method, easily you can find the complement of A. That is universal set difference A. So for B, B dash is equal to U difference B. So for A union B whole dash, U difference A union B. So here we got A union B. So I will use U difference of A union B. So what is A union B here? A union B is 2, 4, 5, 6 and 8. So now you just check the set element of universal set with A union B set. So how to find the difference of two sets? Already have discussed. So here you just check the set element of A union B with universal set. So which is a common in both the set? 2, 4, 5, 6, 8 is common in universal set as well as A union B. You just skip the common elements and just write the remaining element of universal set, that is 3, 7, 9. 3, 7, 9 is your A union B whole complement. 3, 7, 9. So now I will prove this A dash intersection B dash. So find out A dash first. Universal set difference set element A. So universal set and check the set element of A. Universal set and A. So 5, 6, 8 is common in both universal set and set A. 5, 6, 8 and 5, 6, 8. So just write the remaining element here. 2, 3, 4, 7, 9. Common is 5, 6, 8 is common in universal set and set A. 5, 6, 8 is common. Then write the remaining element 2, 3, 4, 7, 9. So this is your A dash. Then find out B dash. So the remaining element of universal set is 2, 4, 5, 8 is common. So 3, 6, 7, 9. The remaining element of universal set is 3, 6, 7, 9. So now again find out A dash intersection B dash. So A dash is 2, 3, 4, 7, 9. B dash is 3, 6, 7, 9. So now find out A dash intersection B dash. So which is a common element in both set A dash and B dash? 3, 7, 9 is common. 3, 7, 9 is common. So this is your RHS. So what is our LHS value? LHS is equal to 379 and RHS is also equal to 379. So therefore LHS is equal to RHS. So very simple concept. Here you can use the De Morgan's first law or second law. You can prove that LHS is equal to RHS. So first consider the LHS value and prove the value of LHS. So first find out A union B, then find out A union B whole complement. Then consider the RHS value. First find out A dash and B dash. Again find out A dash intersection B dash. You will get the LHS value and RHS value equally. So this is your De Morgan's first law. And what is second law? A intersection B whole dash is equal to A dash union B dash. This is your second law. So this is your assignment question. Please practice this second law of De Morgan's theorem. Prove that LHS is equal to RHS. So today we learned the problems on laws of set theory. So using the set elements of A, B, C, easily you can prove the laws of set theory easily. So this is called as laws of set theory and problems. So in my next session, I will come with a new concept called counting. Thank you.